Early megaphones were simple cone-shaped devices that focused sound forwards so it was projected further and could be heard more clearly, or not as the case may be. In the 20th century, microphones, an amplifier and a speaker were added to the cone design to really ramp up the volume. Waterproof versions like this one are designed for sports coaching, law enforcement and military use. So please, lend me your ears as we hail this clever device and sound out how it's made. Production starts with a panel of 4 digital circuit boards fitted with tiny gold pads. A stencil is placed over the panel so that the holes in the stencil align with the gold pads. Solder paste is then squeegeed over the stencil and onto the exposed pads. This is a circuit board before and after the solder paste application. Robotic arms then install electrical components on the solder-coated pads to create circuitry. Various reels unwind to deliver these miniature parts. The robotic arms suction them off the delivery system and transfer them to precise locations on the boards. These parts will control the megaphone's sirens, horns and microphones. A completed circuit board is then clamped in a fixture to test it. Spring-loaded pins underneath make electrical contact with the components to evaluate their performance. At the next station, a part known as the front can is attached to the end of a flared speaker cone. Attention now turns to the speaker itself. Screws are first inserted into the base. Wires from the speaker are then threaded through a hole in the cone, followed by the front can. The speaker is then placed inside the cone and screwed into place. A connector is now attached to the protruding speaker wires. The exit hole is then filled with epoxy resin to waterproof it. A UV light is used to cure the epoxy in seconds. A metal mesh is placed over a hole in the rear can. As the mesh is forced into the hole, it takes shape to form the microphone cover. The newly formed cover is then removed and fitted to the microphone. It's crimped around the sides to ensure a tight fit. The microphone is now placed into a tube fitted with a sliding inner sleeve. The tube is then inserted into the hole in the rear can. The inside tube is then slid down, which pushes the microphone into the hole. A knob is added, which will turn the megaphone on and adjust the volume. A small circuit board linked to the siren and horn control button is then installed. Small spring pins will mate to a battery, which will power the megaphone's circuitry. The pins are tucked into moulded protrusions inside the rear can and are waterproofed with rubber seals. The megaphone sub-assembly is now ready for the main circuit board. Wires for the switch trigger, microphone. A silicone O-ring is then fitted around the rim of the rear can to seal it. The rear can containing all the working parts need to be connected to a temporary battery and powered up for a sound test.
Check, 1, 2, 1, 2, check, testing, 1, 2, check.
So far so good, but more sensitive testing is also required. To do this, the megaphone is placed in an insulated chamber to remove any background noise. A computer runs the megaphone at different frequencies and analyzes its performance. The addition of handles completes the unit, meaning all you have to do is clear your throat and get on your soapbox. This is how it's made.